And let's see here. This is what I would have sounded like if I was actually using the right microphone. So I had a microphone in front of me this entire time, and I was using the wrong one. So let me know if this one sounded better. Professing to be wise, they became fools. Look, guys. This website, World's Last Chance, they've done a lot of good research in the past. They figured out the lunar Sabbath. They've looked at the Bible. But their reasoning for why they think the earth is flat, it's not biblical reasoning. Their reasoning has to do with a measurement taken. For how far you can see across a distance. Now, they've already done all sorts of calculations, thousands of years, with shadows, to determine where the sun would be coming from at certain times of day. And they've determined that either the sun would have to be refracting through some sort of medium which makes it come from different angles, or we live on a globe. But there's no math model that would support just a spherical sun that's rotating around in a circle above a disk. None of there, you'd have to account for a major time dilation, not a small one, but a major one, which we have cell phones, and we know when we talk to someone that their response is not only instant, but also the way they perceive time moving forward. Look. Newton made an assumption that time was constant. There was a big clock that someone could make and say, this is the clock of the universe. There's a big ruler someone could make and say, look, you can look at this from any distance and measure everything. But in reality, that was just an assumption. So when Einstein came along and was trying to figure out why is it that it doesn't matter how fast you're going, the speed of light always seems to be exactly the same thing. And when he figured this out, he wasn't coming up with a new theory. He was removing a false one. He removed this assumption that we have about what time is and what length is, and that it's the same no matter how fast you're going and no matter which direction you're moving in. That was just an assumption that he removed. So when they say his theory explains gravity, what that means is that gravity was introduced as this concept called a force. And a force is just a measurement in physics. And when Einstein wrote down his theories, this force was no longer there. It wasn't an added force that you had to say, okay, we gotta add gravity to this equation. Whether we're building a flying machine, or an airship, or a cart, or figuring out how a horse needs to move, or when we're building a structure, when we're building a big 2-3 story building or church, we no longer have to include this force as a calculation when we're doing all the calculations the way Einstein presents them, because it no longer existed. Everything would fall just by existing as it was, and it would fall exactly according to the original force that was there. And this is after you account for when you add mass, when you add something heavy, and it pulls in, it stretches the classical space, the classical time, the way that we had already been measuring time, the way we already perceive it and assume that it works, the way we already add it up, the way we already add up and use length, like with rulers. We assume that we can apply the Pythagorean theorem because we're assuming, remember, that it's a Euclidean universe. Well, in this universe, it's you're like on the surface of a hyperbola. You're not on a flat plane, you're on a hyperbola surface. And when you start measuring time and space across this hyperbola, and you also, it's not just a regular hyperbola, it's a stretched one that stretches when you have mass. So when you remove this assumption that it has to be a perfectly flat, perfectly straight, perfectly perpendicular piece of paper plane, and you realize, oh no, that was just added assumption that we had no reason to believe was absolutely true. In reality, it was just an approximation. Well, when you do that calculation for, say, somebody walking around, and you say, hey, I want to convert this person walking around back to a flat perspective, a flat, and flat as in space-time flat, not the ground being flat, but the space and the time distances themselves, and how much time will pass. When you take that hyperbola and you try to straighten it back out again, you have to account for this, what was actually happening. You have to take what was actually happening in the original and convert it. So if it turns from something that looks like it's staying still to something that's like, well, why is this moving? Why is everything falling, like pushing towards each other? Then you have to say, well, we have to add this force. Okay. Now, when you go look out over a distance, you have to account for lots of things. You have to account for how far you can see according to the regular trigonometry. But you also have to account for the space-time itself being curved. Because, remember, it's not a force. It's just the curving. It's just the distance, the movement that you see when you draw everything according to the hyperbolic system. So when you look in the hyperbolic system and you ask, what happens to this light? Say you're looking at a building really far off in the distance, like the Statue of Liberty, and you see it really far away. Well, what are you going to actually see in this hyperbolic model that accounts for everything, where you don't have to add gravity as a force, where it explains exactly why light is where you can treat light normally instead of having to somehow trick it into going the same speed as everything else, but also adjusting clocks and adjusting lengths. In this hyperbolic system, you don't have to adjust anything. You don't have to adjust speeds of light. You don't have to add gravity as a force. You don't have to change the lengths of times or of anything. Everything just is how it is when you draw it that way. Now, it's sophisticated It's four-dimensional. So when you draw a basketball, it's not just a ball and then you say, hey, it's going to move. You draw a worm of the entire lifetime of the basketball. There's a start, there's an end. If it bursts into pieces, you split it. This is a worm shape, but it's not even just a 3D worm, it's a four-dimensional. This is not just something that people can just see unless they see slices of it. This is a more sophisticated model, and it's not very sophisticated because you can also make like you can make a 6-dimensional model that takes into account things and where events are actually spheres in this model, and there's no the time dimension is not perpendicular like that. But this is just a simple enough model for these mathematicians to work with, and they have what's called a Lorentz transformation. But the point is, the distance formula, that's what you have to keep in mind. You have x, y, and z for space, and then you have, so x squared plus y squared plus z squared minus t squared. Those always equal the same space-time distance. It's not a distance between my finger here and here. It's a distance between a snap and another snap. So if somebody's flying by and they disagree on how far my fingers are apart, and they also disagree on the time, but their distance between the snaps is always going to add up to exactly that same number. That's how it works. And the Lorentz transformation is just a way to, that complicates the math because it brings it down to our level and tries to explain the math from our perspective, where we want to see everything as screenshots or as instants in time or as video, because we want it in 3 dimensions or in 2 dimensions. We don't like it in 4 dimensions because that's too, we can't make pictures of it. So these people made this website, and when you listen to their arguments, sadly their arguments are wrong. They need to go back, they need to do the calculation that takes into account, that just uses space-time curving. That's it. You don't add gravity as a force. They'll say that gravity doesn't exist. They'll say it's just density. Maybe some flat earthers will do that. But that doesn't account for the direction. That doesn't account for the fact that you can measure a force the same way you would any other force in physics. So you can use a like a scale or something like that, and that's a measurement of force. So we have that. We have the opportunity to go check that. We have the opportunity to go out there, draw a line, because when you look far enough out, it's not going to be like that compared to the ground. It's going to be a curve. And that means when you see something, you're not going to see it at the same angle, you're going to see it. So if say it's supposedly pointed away from you some, so you're saying, hey, if the earth was round, then why am I seeing it? Well, why does it look like I'm seeing it from the side? Well, light will curve a little bit. You have to take that into account in your calculations, because light is just following the straightest path. And the straightest path, when you stretch space-time like that, so that the straightest path will look curved from a distance, from the side. But as you follow the path, it's the straightest path. It's going through the least amount of space. Basically, it's how it works. It's when you stretch a rubber band, after you drew a straight line, if you stretch the rubber band and you draw another line, is it going to be the same line? No. One of them is going to be curved depending on whether you're stretching it And whether you condense it back, then the other one will look like it's straight. That's exactly what's going on with that. So take into account the curvature, and if you're going to draw a picture from the side view and say, look, here's the person on this side, here's the building on this other side, and he's looking at the building, remember, that's a side view, which means you're already assuming, if you try to say that the line needs to be straight, you're already assuming trigonometry. So you're assuming what Newton was assuming, which we have zero reason to assume, because you can't even assume that for a piece of fabric or a trampoline or anything like that. So I really appreciated what they did there. But, Song of Solomon, unless you believe that a neck is a tree, and you might say, well, the Bible, it doesn't use those, metaphors. Okay, well, what about when it says that uses metaphors? Like, what about when Nebuchadnezzar was having a dream and Daniel said, this is that. This head is a kingdom. Or the sheaves of wheat were Joseph's brothers. Those are metaphors. So we have to study that and understand what is going on with this. Are they metaphors? Why would there be 4 foundations for the earth? What is it? What is that talking about? Is it talking about physical pillars, or is it talking about something else? But you can't use the argument that they're using it, World's Last Chance. That argument doesn't make sense. Doesn't add up. It doesn't use math properly. So, Pythagorean's theorem, you can use it on different surfaces, but remember, if you use it on a sphere, what do you get? You can make let's just say you want to use some trigonometry, and you're drawing a triangle on a sphere. Well, you get a triangle with 3 90-degree corners, right? So that assumption of a plane is also true not just for the Earth's ground, but it's also true for space-time itself, for the stretching of space-time and light. Because these people will not be able to explain to you why it doesn't matter how fast you're going, light always comes out to be the exact same speed. Like, if I'm on a train going 100 miles an hour and somebody's on the ground and we're both looking the same direction, why are we both measuring the speed of light in the same direction at different speeds? Why are we both looking at the same object too? So the object is going to be going, and it's still, we measure exactly the speed of light compared to the guy on the train and the guy on the ground, right? Does that add up? It should be 100 miles an hour more no matter what, right? Only if you assume the Euclidean world, the Newtonian physics. We're not in a Minecraft world, and that world wouldn't make sense, because if you looked in the sky, what would you have? You'd have these infinite stars, and all of them would just be giving you the same light, and it would just be, we'd be consumed by all this energy, because the entire sky would just be pure burning energy, light, and you'd be, how much energy how would you, every point in the sky would be a star, because it didn't matter how far the star was, there would be no space-time stretching to redshift it. So instead of the sky being dark at night, it would be completely covered, it would be completely bright, it would be consumed, it would be burned up. So these people, they oversimplify things to the extreme, and they don't understand. And I had a friend, sadly, who apparently he was an engineer and he was building houses and things like that. And we had a house that was on stilts, and I tried to explain, this is why the house is shaking a little bit. And he looked at it and he's like, oh, it looks okay. But it was on stilts, but there were no diagonal supports. Well, when you have a plane and you have another plane and you have direct connections between them, but no diagonals, well, what's going to happen is you're going to have some play, some movement. You would need something to prevent that. You would need some actual corners or some actual diagonal supports. but he's the same guy who was trying to explain that, hey, if we take off in a helicopter, we should just wait for the Earth to spin and then we can just land again. It's not how it works. It's not how it works. Guys, we do have measurements for that kind of stuff. That's where hurricanes come from. That's why we have down in Ecuador, that's why you have like water going around one way and going around the other way on the other side. We have these forces and they're measurable, but they're not going to fling you off of the planet. That's not how this works. You don't have a lot of angular momentum. A day takes 24 hours. It's really sad when some people, you want to stick with the truth and you find out that they didn't really do a good job of it. So thankfully I didn't know about this website before they believed this. I didn't have a lot of kind of emotional or mental investment in them. They were already like this when I found out about them. So, but I do like that they have these resources and that you can look at and get a good overview of when the feast days and when the Sabbaths are and when the new moons are, and kind of convert that to a Gregorian calendar. That's a good, helpful tool. All right, guys. Be safe. Take care of yourselves. Get some rest. And happy new moon. And let's see here. This is what I would have sounded like if I was actually using the right microphone. So I had a microphone in front of me this entire time, and I was using the wrong one. So let me know if this one sounded better.